Beautiful. Thank you, Sean, and welcome everyone. The Passive House Accelerator is a collaborative online platform for sharing innovative thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and elevate the work and programming of the passive house movement's leaders, practitioners, organizations through interviews, articles, podcasts, and so on. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house buildings. With our co-hosts Kevin, Shannon, and Sean Santamore, we produce Construction Tech Tuesday. Share the technical, the technique, and the technology of passive house. Each week, we welcome guest practitioners to dive into details of practice with the builder, tradesperson, and our target audience. We welcome folks from around the corners of construction to design a world for each of us every week. Welcome.
Well, good evening. Thanks, Mark. So for those who don't know me, I'm Sean Santamore. I am got a new position. I'm the Outreach and Education Associate with 475 High Performance Building Supply. So again, I'm able to teach and connect with builders on even a further scope now. And tonight, the only thing I need to do to kick this night off is pushing the envelope is going to be at a whole new time tonight. So Shannon, can't wait. I don't want to waste any time. Let's go.
Absolutely. I don't want to waste any time either, because we could talk all night about 75,000 subjects. We're going to focus on one. So I have to apologize in advance. But good evening, friends. I am excited to say tonight is your night. Just introducing one of tonight's presenters would be an honor. And to introduce all three, when they're working together, is beyond brilliant. They've created Fifth and Dinwiddie, which they'll bring you tonight. It's Bridging the Gap Development's newest project in Uptown Pittsburgh, yay PA, and it's set to start construction this fall. It's a 2-building development, which will offer market rate housing, affordable housing, and over 10,000 square feet of retail space. Both buildings are targeting Passive House certification, Reset Air certification, Fitwel certification, and much more. Tonight, we're going to focus on the building science and how it differs from the data science, what early onboarding is, and why it makes a really, really big difference. So please join me in welcoming Craig Stevenson, president of AUROS Group, Derrick Tillman, founder of Bridging the Gap Development, and James Curry, senior associate of Intelligent Buildings at Newcomb Boyd. Take it away, gentlemen. Thank you so much for being here tonight.
So we will try to get into the technical, the technique, and the technology. We're really honored to be here today with so many familiar faces at the Passive House Accelerator Construction Tech Tuesdays. This is exciting for us, and we're happy to talk to you tonight. So what we're going to be talking about today is building for performance on a budget. And our specific focus is going to be how we define high performance, how we manage that through early goal setting, through design support, and most importantly in operations, and how we deal with measurement verification systems on the same budget that we had planned for the original construction project. So the picture you see at the bottom is the development for the Fifth and Dinwiddie projects. The one on the right is a commercial building, and the one on the left is a multifamily, and we'll get into it right now. With that, my name is Craig Stevenson. I am with the AUROS Group. Our role in this project is owner's performance advocate. We are doing the Passive House consultancy. This is a PHI certified project, or it's going to be a PHI certified project. We're doing the goal setting, the targets. We're doing sustainability certification for Reset Air, for Fitwel, as well as Passive House. With that, I'll go to Derrick.
So I am Derrick Tillman. I'm president and CEO of Bridging the Gap Development. I'm also the developer of the project. We are a real estate development firm based out of Pittsburgh. We focus on bridging gaps of opportunity, as well as bridging gaps in development. So when we say bridging gaps of opportunity, really focused on creating opportunities for minorities, for women, as well as the local residents and communities that we're serving. And then bridging gaps in development, which is focused on bringing catalytic, transformative development projects to different communities, both communities that are in transition, but also communities that are already thriving, with sustainable development being a core component to all of our development projects. How do we do that? We do that through affordable housing. We do market rate. We do mixed income. We do commercial real estate projects, retail, office, and been really getting more involved in community and cultural space. Today, you're going to hear more about us talking about sustainability, but more specifically, building performance and where that meets data science. I think my background of a bachelor's degree in information science, which is really unique from a developer's perspective. So I really get it, you know, when these guys are talking about technical terms and just really how all these things tie together, which is why we're excited about this project and really see ourselves kind of leading the way, you know, with that regard. With that, I'll pass it over to James.
Thanks, Derrick, and thanks everybody for letting us present, letting me present. I'm with Newcomb Boyd. We're a MEP, multidiscipline engineering firm in Atlanta, Georgia, and we're unique. We've had a special technologies sector in Newcomb Boyd for over 10 years now. That's really focused heavily on not just building automation technologies, but all of these different disparate technologies that we see converging in all the modern day construction projects, and special technologies at Newcomb Boyd targets to try and combine all of these into converged networks, make sure that we're staying abreast with all of the latest technology and trends, with not just, again, building automation systems, but IoT tech, and including things such as people counting sensors, so that we can track occupancy and utilization, indoor environmental quality sensors, IEQ sensors, which you'll hear a bit about in this presentation. Who makes the best ones? How do they communicate? What's the best way to install them? What are some cost-effective ways to install them? So Newcomb Boyd's really worked hard to try and develop these skill sets with our engineers and our consultants, so that we can help strategically guide designs like Fifth and Dinwiddie for BTG and AUROS Group, so that y'all can learn from what we've seen work in the field. And again, thanks for having us too, and looking forward to fielding some questions about this exciting project.
So as we look at this project, I think it's important to look at the history of sustainability. If we go back to the 60s, we really were focused on dreaming it. This is when there was a lot of conservation and activism, you know, around why these types of issues were important. Moving into the early 90s, early 2000s, when Passive House was founded, when LEED was introduced, it was really in that think it mentality, where you saw the prescriptive standards. Then moving into the first decade of the 2000s, where the performance standards were really created, where we were focused on improving it. And then now, you know, in this, 2020 and beyond, there's the performance accountability and defending it, being able to defend it. Groups like states like New York really leading the way. States like Pittsburgh, or cities, I should say, but also states, Pennsylvania. There's measures being instituted with P4 measures being launched. The city of Pittsburgh really pushing developers and building owners to go to zero energy, that they want us to be able to prove it, defend it, I should say, because eventually there's going to get to a point where if you say you can do X and you don't, there's going to be a penalty for that. Developers like myself, owners, funders, were really looking for proof to be able to really do what we said we were going to do. And again, I want to know that we got what we paid for. So that just really touches on the history of sustainability. Next slide. So, but how do we do that? You know, I think that really it's about the proof of results that matter. This project, as you'll hear all throughout the process, is that we are consistent with the UN SDGs, United Nations Sustainable Development Goals, really showing how the project weaves through all these different components. This is really, core to our mission at Bridging the Gap. It's really important to us, important to our values of, really developing good health and well-being, and incorporating and ensuring that we have affordable and clean energy, but also, all these other things that really matter to me, that we're developing sustainable cities and sustainable communities. What does that result in? Reducing fuel poverty, other equitable and environmental issues that impact air quality. These are the things that really matter, that really is where the rubber meets the road. And, projects like this are advancing and really changing the game as it relates to addressing these issues. Next slide. But the thing is that is very important with these types of aspirational goals is that it doesn't cost more. We shouldn't have to pay more to get these types of things that should be really incorporated into all projects. What we found is that the earlier that you buy in, the earlier that you bring together innovative teams, smart teams to execute these types of goals, the earlier that you really go in this direction and commit to it, that you're able to control those costs and develop Passive House at a cost neutral standpoint. So it's really about committing to it and bringing together the right team from the beginning to be able to make such a strong statement, but ultimately, perform and deliver on that statement. So let me tell you a little bit more specifically about the project that we're developing.
This is Jay Gentry.
So you have on the top right picture.
Hold on, I had that.
The top right picture is 5th and Dinwiddie East. 5th and Dinwiddie East consists of a multi-use commercial building. You'll see the right brick is an existing building. So it's an adaptive reuse that sits at 20,000 square feet. We're also adding a 20,000 square foot addition. So it'll be a 40,000 square foot office building. Within the building, we will have commercial office space, co-working space for some small businesses. We'll have a small retail footprint where we definitely intend to have a coffee shop and something else to serve as a community. But then we're also doing a clean energy jobs program, really focused on training folks in the community to create good paying jobs. We'll be teaching things like how to install solar panels, how to install electric vehicle charging stations, and other types of innovative technology. So we're very excited about that. Moving down to the bottom right picture is the mixed use, mixed income development project. So we're developing, this is all ground up construction, 171 units, 80% market rate, 20% affordable, as well as about 12,000 square feet of retail space. 2 buildings connected by a sky bridge. Both projects will be certified Passive House. Both projects will be Fitwel certified. Both projects will incorporate reset air. And the west, which is the multifamily building, will also utilize offsite construction. And also the smart building infrastructure. This is where the building performance meets the data science to really be able to ensure and measure that all these things that we say we're doing, we're able to measure that and show real-time data that we actually executed on the sustainable development goals that we incorporated. So here with the OPR, the owner's project requirements, this is really our roadmap. This is how I hold my team accountable. This is also how they hold each other accountable to ensure that my goals, values, the things that are important to me, that we really execute on them. There's a clear document that everyone is committed to, that really lays out everything that we said we wanted to do, and it keeps everyone, on target all throughout the process. So we really commit to this from day one, throughout the duration of the project. So with that, I'll pass it over to Craig to talk about this a little bit more.
Thanks, Derrick. There's a few other things I'd like to add with regard to the owner's project requirements. Most of the architects in the room are probably looking at this and saying, yeah, we do that. We handle this on our project. We do it all the time. I want to just highlight a couple fundamental differences between the way in which this project is using an OPR and the way in which we've used it traditionally. First, the OPR is a single page and it's evidence-based. It's based on empirical data. So there's not a lot of copy in there. There's not a lot of fluff. There's not a lot of discussions around theoretically what we can do. We are going after metrics. We're going after evidence-based criteria. So we work very closely with the entire design team to craft the OPR when we start the project. Second, the OPR is a working document. So if you think of a schedule on a project, the contractors come on board, they produce a baseline schedule, and then every couple of weeks they'll update that schedule and share it with the team, and it becomes this working document as you work your way through the project. Our OPR is the same exact way. When we start the project, we have goals and aspirations. We create a baseline. And from there, we'll hit our constraints on a project, just like every project does. You're going to hit your financial constraints. You're going to hit your schedule constraints. You're going to hit your constructability and what you can and can't do. And we want to adjust the OPR. So like Derrick said, this gives us our guidelines, our swim lanes, if you will, in terms of how we want to define sustainability and make sure we reach it. So we want to update this working document, and we update it frequently. We use it to realign the project teams. Sometimes the project teams, through a lengthy design period of what could be 5, 6, 7 months, may just mistakenly go back to code-based criteria, and we want to make sure we reinforce where we're going. So we use this to also realign the project teams frequently on projects, and sometimes we bring in new engineers, and we use it to, again, create guidance. The next thing we do with the OPR that's unique and different is we use it to build use cases. And James will be talking about this a little bit more in his side of the presentation. But it's very important for Derrick. He's laid down the rules when we started the project. If we set a goal, we want to know if we met a goal. So we can do that through metering and sensors. We can do that through other means. To the extent we can do it using technology, we want to. So when James came on board, and he came on board very early, we worked with him to refine the OPR and then start very early talking about how are we going to adapt a measurement verification system that tells Derrick whether or not he's won or lost, because he's making the investment and the commitment into the passive house construction project. So with that, we want to talk for a second, and I'm going to go through this slide relatively quickly because of the room. I believe that the room understands this very well. There are smart buildings, right? So you have code-based buildings that have been constructed to code-based criteria, and they throw a lot of technology at them. And they hope that that converts the buildings to high-performance buildings. If you don't respect building science and you don't respect the natural order of sustainability, you may not get as far along as you anticipate by throwing a lot of money at technology. Then there are high performance buildings, and we use this Cornell Tech project as an example here, only because it's a very well-known, well-done passive house project. And high performance buildings don't have to be smart. They can be stupid. Not that Cornell Tech is, they have their technology. But the point I'm trying to make is that we build passive houses, and sometimes we don't measure and verify those buildings, and they don't have to be smart. But when smart buildings and high performance buildings merge, special things happen. That's when we can operate buildings for 50 years at the performance levels that were intended during design. That's the difference. That's where our focus is. Our focus isn't designing a high performance building. Our focus is not constructing a high performance building. Our focus is in operating a high performance building for the next 50 years. And that's what Derrick is mandated for the project team. So how do we start doing this at the 5th and Dinwiddie projects? And I'm showing you example of West. This is West. So we start in conceptuals. The architects develop the architectural program. They make sure that the building has the pro forma that Derrick needs from a revenue perspective. They make sure it has the right flow and it has the right look for what Derrick wants to do. And then immediately we get into an iterative process of energy modeling and estimating. So as the design progresses and it goes into a Revit model, we're updating the energy model iteratively. We're not waiting until the end of schematic development or design development or the major phases of design. We are literally doing this iteratively. We're checking our estimate and our control estimate and our energy model profiles on an ongoing basis. And for most people who practice passive house that are most of this room, you understand that as you go through your massing and orientation and your envelope optimization and your system definition, you have to be able to go back and double check the energy model to make sure you're on the right path. You have to be able to go back and double check the pricing to make sure you're on the right path. And that's what we've done. This project is also using offsite construction. We're using a vendor that this passive house accelerator is very familiar with. They presented here a couple of times. It's Blueprint Robotics out of Baltimore. They've been an incredible partner for us on this project. They've helped us with wall optimization. They've helped us with a lot of different criteria on the project. And again, using offsite construction, you need to bring them in early, like conceptual, and you need to iterate them while you're doing the energy model and the control estimate. You need to be iterating with the offsite construction vendor. If you miss that or try to bring them in later, you're either going to end up paying a premium for it or it's just not going to work. And for us, it's worked really, really well. At this project here on West, we're pretty much at the mid CD. So we're in the final phase of design. We should be done within about 30 to 60 days, and then we'll be looking to begin construction in the fall. And everything is coming together from a budget perspective and from a design perspective. East is farther along. East will be breaking ground, I believe, in the next 30 days. When we work with developers, we always talk to them about this merging of building science and data science. This is extremely important for us. It's as important as respecting building science and the natural order of sustainability, passive first, active second, renewable last. If you respect building science and the natural order of sustainability and you respect data science, you can develop systems that are going to give you the right feedback loops on these buildings. And what does that look like? Well, if we're setting zero energy and zero carbon goals and world-class indoor air quality goals, we want to know whether or not we've reached those goals. It looks like this. This is as simple as it is. We can take hourly and sub-hourly data, real-time data from our simulation, and we can integrate it into our dashboard technologies. And that's what we've been doing on this project. It's one of the capabilities that we have, is that we can take all of this data and we can superimpose it. So we can see real time if the building is performing as it was intended. This is an example of gas, but we can do this for all forms of energy: gas, electric, district energy, steam, and chilled water. We can do it for cogen, renewables, and we can also do it for indoor air quality, for temperature, humidity, and CO2. And if we can do that, then we can set up notifications, we can set up alarms, we can set up technologies that work to change the way in which the building operates to make sure that the building is performing as it was designed to do so. And this is as easy as it looks when you're done. It just makes it simple for the operators. It essentially connects design and construction to operations in a way in which that really doesn't exist in the market. The passive house world is physics-based data, right? So when we talk about this, and this is where James is going to come into, we needed to identify, how do we get the data from the building? And what do we do with it? Where does it go? What do we do with the simulated data? I can get the data out of the models, but where do I put it? And how do I make all this work? Do I kick it to the building automation system and let that handle it? Do I move it to another platform? For us, it's all about getting the data and getting the data to a point where the owner owns the data. This data is not owned by a proprietary vendor. It's not owned by a software service. Derrick, at the end of the day, will own his own data in his data lake. So we're taking all of the building performance data out from the meters and sensors, which are built from use cases from our OPR, and we're taking the simulated data and we're bringing in this data lake. Once we get into the data lake, we can share it off to Reset Air, Lead Arc, so we can share it to sustainability programs. We can take the data and we can run analytics on top of it. So when you think about advanced analytics like fault detection, diagnostics, condition-based maintenance, all the overlays, they basically lay on top of that data lake and they can do their job very, very well. We no longer have to worry about piecing it together. This is also referred to as a single pane of glass. So all of our operational technology data from building automation systems, Reset Air, indoor air quality sensors, fire alarm security systems, all the operational technologies all come into a single data lake. And we apply as much simulation on that as we can, because simulation is the right context when you think about how to operate a building. You want to operate it as it was intended to be in design.
So that's a great segue, Craig, and thanks for that. And I always appreciate the data lake slide, because a lot of folks out there, they're not on board with the idea of a data lake. But for this project that we're talking about, Fifth and Dinwiddie, it's a very technology centric project, and the amount of points, if you're on generally on projects where there's big BAS, building automations systems, a lot of times you'll get pulled into conversations about point counts, and you'll hear numbers in the tens of thousands oftentimes. So this isn't Fifth and Dinwiddie, is not a massive hospital or a building that has a highly complex mechanical system. But one of the draws, it does have all the amenities that modern retail and residential tenants alike are growing to expect. These are things like wireless access points and internet inside and outside of your residential unit, seamless. Smart building automation system that allows action or inputs in one system to affect or alter a point in another system for an intended outcome or measurement point. So for instance, if you want to have proactive maintenance, Fifth and Dinwiddie is also going to have a smart lighting system that is also ingesting information and sending it out to be trended in our data lake. And it's for both interior and exterior, and it's operational in that it reacts based on occupancy and conditions, but also on things like daylight. So this project, I'm not sure if we've talked yet or seen a rendering, is also going to have solar panels on the roof and EV charging stations. These have, especially in residential and multifamily, an immediate effect and impact on likability and saleability. So these are all technology features that people have now grown accustomed to in the commercial sectors. But when planned and designed properly, these benefits can and should apply at the home and in our communities. So we talk about technology. We can go to the next slide. Let's look at some of the systems that are involved. And I'll try and not make any acronyms or mention any acronyms without telling you what they are at first. There's a consolidated network, or ICT platform. That's information communication technology, which is the network layer of the equipment and the managed platform that carries and secures all technologies in use. This is physically comprised of network switches, firewalls, categorized cable, all structures supporting the equipment for each system. But with all of these data, the points going into our data lake, most of these technology systems, the sensors, the services, the field devices are increasingly IP based. So as such, they also have to be hardened and protected. So this ICT platform is also comprised of policies for information security, network traffic management, network segmentation, and an overall access management. We coined this ICT platform the operational technology, or OT platform. So the operational systems include things like Derrick mentioned and what Craig was talking about further about security and access control, video surveillance. Fifth and Dinwiddie is going to have a comprehensive access control and security system, and it's sitting on its own dedicated network segment, or VLAN. Another system that's going to be in place here at Fifth and Dinwiddie is a Niagara-based system that controls all of the HVAC equipment. This is rooftop units, exhaust fans, indoor air handling equipment, taking information literally from hundreds of sensors. So for example, we talked about indoor environmental quality, or IEQ. Each residential unit is going to have at least 2 IEQ sensors in it. There's over 170 of these. These are going to be providing real-time conditions throughout the residential units, core and shell too, the whole building. So it's a ton of data streaming. Indoor environmental quality too has become a major driver in both commercial and multifamily construction over the past year for obvious reasons. But this is all going to be funneled back through our OT core system, channeled through, in this case, a Niagara-based system. It can conduct point analytics, but also give the data lake and its analytics platform the capabilities to model it however it needs. So another instance about the BAS, we're not expecting that, say, the landlord in this case can actually control the units inside everybody's residential unit, but it does integrate to all of those units in each of the residence units so that the facilities and maintenance team can better serve the residents if one of those unit systems goes into alarm. So managing all of this is it's a big task, and it's up to trying to design this as methodically as possible in advance, and so that we're not stepping on, or contractors aren't stepping over one another. So what does this look like? Go to the next slide.
So James, before we do that, let me
Sure.
jump in for one quick second, because our theme here is that we're doing this on a budget. And I want to reinforce for everyone who's listening how this is done, because you're probably thinking like, oh my God, this is $1 million. It's actually not. We have two options when we approach a project like this when we want technology. We can go find a proprietary vendor and let them bundle it all up and then buy them, and they own the building for as long as they're in the building, and they're extremely expensive. So we can go get a Johnson Controls that wants to do more than just controls, and they want to get into occupant densities, they want to get into lighting control, and they want to get into security. And we can do that. And I use Johnson as an example, but Honeywell or Siemens or any of the providers out there that are trying to control the entire building, we're not doing that. The second thing is the networks. Think about the network. So we buy a fire alarm. The fire alarm vendor wants to come in our building and run his own copper all the way out to all his own switches. And then you talk about security, and they want to do the same thing. When you look at the 25 different operational technologies we have going on at 5th and Dinwiddie, everybody's coming there and setting their own copper down and running their own networks. That's a huge waste. What we've done here, and I'm going to simplify this, is we've ran one backbone, fiber backbone across the building. Every device taps into that backbone. We've converged our networks into one network. We've saved a lot of money doing that. Instead of going to a proprietary vendor to own the entire building and own Derrick for the next 20 years, we've made every technology system open, not just open protocol, but open integrated, which means that with the right licenses, anyone with the capabilities and credentials can go in that system and work on it. It has saved us a tremendous amount of money. We've been able to take those savings from the converged network and the openness of our operational technologies to reinvest it into additional operating technologies that Derrick may not have considered. He may not have considered a really advanced lighting system, but now he can afford it because we have a converged network and we're not buying proprietariness. So again, I wanted to reinforce the value that this team has brought forward with the leadership of Newcomb Boyd, is to consider how to do this and take that budget and reinvest it right back into the project so we can maximize every single dollar that was invested in the technology in this building. And we did it without changing the budget for the controls as we began this project. And that is really kind of the big story here.
Right. Thanks for that, Craig. I appreciate those words. So this diagram here is a lot to get through, but it is it's something that we're seeing more and more owners request, and we call it division breakout riser. Obviously, everybody's probably pretty familiar with the standard type of divisions, but we call these swim lanes, and they're intended to illustrate typical equipment that's going to be installed and connected as typical on a particular floor and also in a particular network segment. But it also illustrates, the division responsibilities of who's installing it, who's responsible for installing it or programming it, and also who's connecting it. This type of a riser diagram is kind of busy as it is, ties directly to the Div 25 specification. This is an integrated automation specification that really kind of sits on top of a lot of the trades to define roles and responsibilities for each one of these folks. This is what we call an MSI model, Master Systems Integrator modeling. And this is the methodology that we started with at 5th and Dinwiddie, instead of trying to adopt or shoehorn a JCI or a Siemens into after or a post award for BAS. What we're doing is we're level setting. The MSI model places integrated automation and the Master Systems Integrator, again, on top of all the other trades and technologies. And this is synergistic because one entity is coordinating and accounting for all the systems and subsystem points. We've seen and continue to see cost savings on projects that use this MSI approach because they methodically reduce overlap in each of the subsystem trades. For example, again, to pick on a BAS or like a JCI or Siemens, a traditional building automation system platform, he uses his own network infrastructure. So does the security system installer. They're all going to come in, put in a temp network, and you could have controlled this from the day one. So at Fifth and Dinwiddie, we want to control this. We design the network on which all of these other entities are going to use. Firewalling security system, firewalling for these provisions, the security for these types of systems, the owner owns and manages it so that we don't have some of the risks that are hitting the news these days about things like hacking. All of this too takes all the network structured cabling, takes it out of the subcontractor's bill of materials. And intended and the realized outcome in this case is that many of these vendors in this model, especially the subs, MCs, and ECs, have a real sense of relief once we've gone through the explanation of this model. They have a sense of relief that they're either not missing or duplicating any scope because everything's mapped out for them ahead of time. This is a construction document issued with everybody else's points to specs, references to everybody else's specs. And it's intended for full transparency so that everybody knows exactly what they need to do, where the responsibility starts and ends, and who's taking the ball, in this case, all of the data aggregation across the goal line.
So there's one other thing I want to add here is, James will be very excited to put as many meters in this building as he could fit. He could tell me what comes out of every outlet. Just remember our goals. Our goals are to use cases, tie the OPR to our measurement verification system. So what you're seeing in these two slides are actual drawings from the Fifth and Dinwiddie projects that are identifying meters and sensors that are tied directly to our OPR. And that's how we're able to do this and make sure that we can maintain a budget for it. There's also a really great story in here. When you look at the middle of the page, you'll see that lower WAN gateway. We've gone through a couple different iterations on how we're going to get the indoor air quality sensors into every living unit. 171 living units all have 2 IAQ sensors in every unit. They're going to know what their air quality is over 6 parameters of air for reset air, which is PM 2.5, PM 10, temperature, humidity, CO2, and TVOC. And James, I think I may have just passed you on acronym usage. So ha. But the lower WAN gateway, when we actually landed on this, we had to work with the vendors to develop this. And this is what Newcomb and Boyd really kind of brought to the table. We ended up saving about $450,000 in structured cabling going to a lower WAN gateway on this project. And it's when you're working with a project team that is super focused on where you want to go and how you want to get there. Culture of this project, openness, open technologies, and transparency. We were able to basically find this solution on this project and unlock savings of, like I said, very near $500,000 for the IAQ sensors, which we're extremely excited about.
Yeah, and Craig makes a good point there that if you approach a project like this with this kind of attitude, right, about we can do something, we can use open protocols, and we don't have to just take what somebody, maybe a BAS contractor says is gospel, then the opportunities just to explore ideas like, say, can I put a lower WAN sensor in lieu of a wired sensor, actually become real game changers. And this is a point of reference. I used to think serial communications cable, everybody knows it as twisted pair, right? It's cheap. You can string it up. In some instances, you don't need it in conduit. And pricing now, unlike probably what everybody else is seeing in the market, is skyrocketing for some of the most simple things, not even EMT conduit. We're talking $4 a foot on a serial cable. I've got a lot of serial cable in these buildings if I don't use a lower WAN sensor. So this is a huge cost saver. If you go the traditional BAS route that may rely on older technologies like this, you're missing out and for no reason.
James, you'll remember our goal in this project in phase 1, or when we go through construction, was to have 20% of the living units and all of the all of the low income units covered with indoor air quality sensors. When we switch to the lower WAN, we're able to basically cover 100% of the units. So every unit now is covered with indoor air quality sensors because of that savings. All right, thanks, James. So again, we're talking about this integration of building science and data science, and it requires the entire team. So when we talk about how do you do that, how do you get there, right? We started talking about this extremely early. Derrick had the foresight when he built this team that he brought together an incredible architecture firm, mechanical engineer, and he brought our team aboard early, and we brought in Newcomb and Boyd because, you know, we've worked with them on other projects and we know their expertise. We started in conceptual, talking about a measurement verification system. And I know that at this Tech Tuesday, most of the people listening are passive house practitioners. It's synonymous with you guys bringing on the CPHC and D early, and the verifier or the QA/QC vendor early, right? You want them in early. They're doing peer review and drawings. They're helping you guys start to think about how you're going to do your testing on the project. That's the same exact approach we took towards the measurement verification system. Respect the natural sustainability, bring the team in early, align them, realign them, and one more time, realign them. And then you can really kind of get to your goals without paying a premium in cost of construction. So what are the no regrets moves, right? And this is something to consider for every project that you're on. We use an OPR to set metrics-based goals. We believe that even if you're using an OPR in a more traditional fashion, get to your metric-based goals. It feeds your energy model. It feeds your measurement verification systems. It's super important when you talk about metrics, because all of a sudden, our mechanical, electrical, plumbing engineers, our system integrating engineers, now these guys know where they're going. These people, the guys and girls, they know where they're going. They know what to design to. It aligns them. And now all of a sudden we can discover things like a lower RAN system because we know exactly where we want to go.
We definitely, we have to have open protocol systems. And for folks that aren't as familiar with BAS practices, these are things that BACnet is our standard now, ASHRAE standard open protocol communication. More often too, we're seeing, again, progressively minded IoT manufacturers, building automation systems manufacturers developing REST APIs. Now, I may not even need to have a serial communication or BACnet communication if I can write to a REST API from a new IoT sensor that's, you know, cutting edge technology. But regardless, when we talk about demanding open integrated systems, absolutely, it's a non-starter anymore for any manufacturer, but definitely somebody dealing with IP and controls, to try and lock you into saying, listen, I'll give you all the data that you want, but you need to pay me SLA annually, and you're never going to be able to actually port that data unless you use my proprietary language and server-based system, etc.
And every time I want to get in there, I got to call you.
Correct. Roll the truck. If you need a new program or a graphic update because you just added a new feature in your system, you have to roll a truck every time you do that.
As someone who's written APIs for proprietary systems to get the data out of those systems, I can tell you this bullet number 2 cannot be overstated. It's super important if you want to get to the data side.
Absolutely. And there's entities out there too, Craig. I was going to mention, sorry, there's entities out there that know the gig is up and they are adapting their older systems. But the majority of master systems integrators, MSIs, are consummate controls contractors because they all came from trained Siemens, Schneider, Honeywell, or Johnson. And they know the game, but they also know all the open protocol type players because they realize it's become a commodity. Controls in general, field hardware, have become a commodity that everybody's becoming to expect, not want, expect on these types of projects.
Yeah, the gig is up is a great way of putting that. So the third bullet point here is establish crystal clear RFPs and specifications. Again, working closely with Derrick, he's had the great foresight to see this and understand it. So we were able to help him write those RFPs to onboard the design team, all of the sub-consultants. And then we started onboarding all of the other team members we needed on the project, the master system integrator, the contractors. As we bring them on, the RFPs are really saving us time and money because we're aligning them to exactly where we want to go. So they're not coming back and saying, well, I didn't know you didn't want a proprietary system. That's going to cost more. We've aligned them. They know exactly where we're going. They know culture of the project, and it's saving us a ton of time and money. We don't have to get to a point and go back and do rework because we're so aligned early on the project. Now it's just a matter of execution.
Indoor air quality, IEQ sensors that we've got on this, but then anything that's going to be a reset project, which are just absolutely cascading in popularity. It does depend on, open systems and protocols, but continuous information flow for certification and ongoing maintenance, proving what you've told soldier tenants, soldier retail tenants, soldier residents. This is an IEQ reset certification. Getting this information out is 2-3 degrees past the conversation I was just having about proprietary information.
Right.
Easiest way to prove this type of use case here is looking at reset and IEQ. Even the sensors themselves now are commodity. They're commodities themselves, but they've all stepped up and recognized I need open protocols. I probably need REST APIs, and that portability of data is the new currency. I hate to use common new catchphrases, but it's true. Data is a new currency. And so when you empower people like this, especially when we're talking about indoor environmental quality after the year we just had, nothing is a better use case than a situation like this to just absolutely liberate your data from real-time measures that affect how we live and breathe in our residencies and in our in our commercial places, our offices.
Thanks, James.
Also, let me add one more thing to that. For me, having connectivity for all these issues, it really connects to a higher purpose. We're not just pursuing aspirational goals to pursue aspirational goals. It's not just about sustainable development just to say we did X, Y, Z. And we're not just collecting data to collect the data. For me, it feeds back to things like environmental justice. It feeds back to, doing social good. It feeds back to reducing fuel poverty. It feeds back to lowering, residents' utility bills. Really impacting, the quality of life for people, having, buildings that incorporate this type of sustainable development goals and these types of technology is really how you deliver that. The data science is important because if, to be able to scale it, for lenders to get on board on a much higher capacity, we need to be able to show that we did what we said we would do. So for me, the connectivity for all these things and why it's important really connects back to, much larger mission-driven goals. So that for me is why this is important. In addition to all the other reasons that we've stated. So here, this is my mentor. His name's Greg Spencer. We actually met when I was a student at the University of Pittsburgh. And I remember when I graduated from Pitt with a degree in information science, actually while I was there, I was in a leadership development program through a group called CORO Center for Civic Leadership. Well, that's where I met Greg. And upon graduation, I couldn't find a job. And it was very discouraging because I felt like I had did everything I was told to do. I went to school, I got good grades, I networked, I got internships, but I couldn't find, a job. So Greg said, you know what, I'm going to help you. So he set up some mock interviews with some of his colleagues and friends in different industries. He was a retired corporate executive. He was a corporate executive at U.S. Steel and also Equitable Gas, EQT, and had started a small real estate company. He was on a lot of boards throughout the city, for-profit boards as well as nonprofit boards. He later started a chemical manufacturing company. But he set up these mock interviews with some of his colleagues and friends in different industries. And, the thought was maybe I was doing something wrong during these interviews. Got some good feedback, met some great people, but basically at the end of it, I still was unemployed. So Greg says, you know what? I'm gonna allow you to come work for me. So my first job graduating from college was actually working with Greg at his small real estate company, managing real estate projects, some small real estate rehabs, and working with GCs, also doing some property management, and helping them with a lot of board work. I met a lot of people, built a lot of relationships, and I really look at that as that opportunity as a springboard for everything that I'm doing today. So part of the reason why we think so heavily about giving back and creating other types of opportunities like what we're doing at Fifth and Dinwiddie East with the training program was the fact that Greg gave me that initial opportunity. So really, this is just an opportunity for us to pay it forward, but just to do it at scale. This was my mentor. We still have a good relationship through today. And, just really shows why the importance of mentoring is that important. So just like to thank the Passive House Accelerator team for, inviting us today. I'd like to thank, others from my team, Craig Stevenson from the AUROS Group, James Curry from Newcomb Boyd. I would be remiss if I didn't mention some of our other team members. Someone asked me who the project architect was. The project architect is GBBN Architects, and they are amazing with the capital A. And also our engineering team and our engineering team, as well as this is civil MEPS is Michael Baker International. So I'd like to also shout them out. And again, thank you all for your time and for your attention to our presentation.
Wow, Derrick, Craig, James. I think we all need a Greg Spencer in our life. I can't tell you how many still shots I took of the monitor. I can tell you I picked up 4 pages worth of notes. My favorite line of the evening was, the gig is up. Data is the new currency. $450,000 worth of insight and intelligence on that project being run by the owners. Much respect, gentlemen. Your community is going to be in such joy with the results of such a fine building. Thank you for delivering this.
Thank you guys for letting us. We're really excited to be here. We'd love to answer questions. We anticipate a few.
The first questions of the night, Craig, are going to be targeted towards James. So Shannon, do you want to jump in with that?
I think we're going to move to Zach and then move into the questions. But yes, get your questions ready for James because he can stay for a few, but he can't stay for the whole after hour. So get ready and line those up.
I can. I moved. So.
Yeah. Oh, I'm so glad, James. Thank you for accommodating us.
So let's see. I have to, I didn't have the power to grab the screen. So now I do again. So I'm going to grab it. Sorry, guys. This is, I think you've blown many minds tonight. So thank you for that. So everything that we do at the Accelerator comes thanks to our sponsors. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxtingwe Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsor is SIGA, and our stakeholder partner is NYSERDA, the New York State Energy and Research Development Authority. Thank you also to our patron sponsors, AeroBarrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Inotech Windows and Doors, Sanderson Sustainable Design, and US Engineered Wood, Teestead. So on the podcast, we've got none other than Chris Ballard, CEO of Passive House Canada. We all know the amazing strides in policy and in adoption of Passive House that have happened in Vancouver, in British Columbia, now in Toronto, and hopefully soon at the federal level. And that's all thanks to the work of Passive House Canada and many people in Canada and their advocacy. So Chris has really great insights to share about that. It's a really important conversation with one of the leaders of Passive House in North America. We also have a bunch of bonus episodes that we're starting to produce based on the interviews that we conducted at the North American Passive House Network's conference in June called Passive House for All. And so these include short conversations with Michael Ingui, with Derrick Tillman, with Craig Stevenson, with Shannon Pendleton, and many others. So please check those out on the podcast. You can also go to our website and look at articles and can see kind of what's been produced so far. We have 18 interviews coming, 2 of which have been produced so far, or have been published so far. The 3rd one will be published tomorrow. Speaking of tomorrow, the Global Passive House Happy Hour, we have a return visit by Natalie Leonard, who will be presenting about fast, cheap, and net zero Passive House. So please join us tomorrow. We just saw the presentation today. It's fantastic. You won't want to miss that. Next week on Construction Tech, we are joined by Rob Hoskin of Building Performance Architecture, and he's going to be presenting about protecting passive building performance and the importance of monitoring and verification. Finally, next week, rather than happy hour, we will be part of kicking off the New Gravity Conference, the New Gravity Accelerated Edition. So this is the conference that Green Building United has produced for many years. This year, we've been invited to collaborate with them to create an accelerated edition that will happen next Wednesday and Thursday. And this is a conference that focuses on passive house and affordable housing, and will feature a keynote by Dr. Kwesi Daniels and some great projects and policies and lots of great education. So please join us for that as well. That's it for me. Thank you. Back to the meat of the program.